Okay, this is the 2015 AP Calculus practice test. In this video, I'm going to cover numbers 15 through 22. All right, in number 15, we've got a graph of g prime, okay, a graph of the derivative. And we're given the information that the original function, g of 0, is equal to 1. All right, and we want to know what is g of 3. Okay, so when you're given the graph of derivative, the way that you do this is you have a starting point, g of 0. So we're starting right here at 0. So g of 3 is equal to the y value at 0, where you start, which is 1, plus the area under the curve from 0 to 3, from 0 to what you are trying to get to, of the graph of the derivative. All right, the area under the curve. So the area we're talking about is that part, a quarter of a circle, and then a triangle. Okay, so the area of a quarter, so we've got 1 plus the area from 0 to 2, it's going to be 1/4 pi times radius squared, where the area of a circle is pi r squared, it'll be 1/4 pi, and then the radius is 2, so 2 squared. Plus the area of that triangle, well, the base is 1, the height is 2, so 1/2 base, which is 1, height, which is 2. So that's 1 plus 1/4 times 4 cancels out, 1 plus pi, plus the area of that triangle, 2 times 1/2 is 1 times 1 is 1. So that's going to be 2 plus pi, which is answer B. So please make a note to go back and study this problem. This is not one we covered in our textbook. Okay, but you could easily see something like this. And I've worked a couple of other practice problems from other tests that are like this, but I think this one is really illustrative of how it works. If some of that graph were below the x-axis, we would have to subtract the area. All right, so I am going to erase. Let's look at 16. So 16, we have f of x is equal to x cubed minus 6x squared minus 15x. We want to know the maximum on the interval 0 to 6. So because they're brackets, 0 and 6 are endpoints that are included. So we have to test 3 points to see what the max is. We have to test the left endpoint, we have to test the right endpoint, and then we have to test any critical point between 0 and 6. Okay, so our left endpoint, you just put in f of 0. So that's going to be 0. The right endpoint, it's going to be f of 6. So that is 6 cubed minus 6 times 6 squared minus 15 times 6. I'm not too super excited about doing that in my head. 6 cubed is 216, and then 6 times 6 squared would be 6 cubed, so that's also 216. And then 15 times 6 is 90, so that's negative 90. So we know it's not 6. It could be 0, okay? And so let's check. Let's find the critical point in between 0 and 6, if there is one, and check that out. So to get a critical point, we take the derivative. F prime of x is 3x squared minus 12x minus 15. We need to set that equal to 0. Let's factor out a 3. All right, so we factor out a 3, and you've got x squared minus 4x minus 5 equals 0. X minus 5 plus 1. So our critical points occur at 5 and -1, but -1 is outside the interval, so I don't care about it. All right, let's do a sine line here. Check to see if 5 is a max. All right, to the left of 5, I'm going to pick, well, you could easily pick 0 because it's actually part of the interval. So let's pick 0, and I'd have a negative times a positive, so negative. So that's not going to be a max. Let's pick 6, that'd be positive times positive. So that's actually a min. So we don't have to worry about 5, so the maximum occurs at 0. And that is answer A. All right, that one took a minute. But you have the skills to do it. Okay, go ahead and pause the video if you need to. $17, so we're going 1 x squared plus 4x plus 5 dx. Okay, so this is one from the later part of chapter 5 in our textbook where we had to complete the square. You have to recognize that this is arctangent. It's the one that doesn't have the radical in the denominator. It would be easy to pick C on this one, the natural log of that, but that's not the answer. Let me show you what we had to do in the textbook. And I think you need to be prepared to get at least one question on this test where they see if you can recognize arctangent. All right, so what we did is we rewrote this, and we used the algebraic maneuver of completing the square. So it's x squared plus 4x, take half of that coefficient and square it, plus 4. Move the 5 to the other side, -5, and then we have to also plus 4. All right, so that's 1 over. And then what you're getting here is x plus 2 all squared. That was the whole point. And then -5 plus 4 is -1. And then maybe it's easier to recognize that, hey, that's arctangent. And they only gave you one arctangent, and it is A. So if it has a square term but not a radical in the denominator, and there's a 1 in the numerator, think arctangent. If there's a radical in the denominator, it's going to be arcsine or arccosine. All right, let's see if we can fit 18 on this board. So we've got f of x is equal to the cube root of x. Let's go ahead and write that as x to the 1/3. What is the approximation for f of 10? And we have a 0.82. So what you got to do is get the equation of the tangent line at 8. And then we're going to plug 10 in there and try to get the approximation for f of 10. Okay, so to get the slope of the tangent line, you got to take the derivative. 1/3 x to the minus 2/3. So what do we plug in there to get the slope? Well, we plug in 8. All right, we plug in that x value. So that's 1 over 3 times 8. I'm going ahead and moving this to the denominator. To the 2/3. All right, 8, the cube root of 8 is 2. 2 squared is 4, so that's 1/12. So our slope is 1/12. So our tangent line equation is y minus y1, y minus 2 is equal to 1/12 times x minus 8. So y is equal to 2 plus 1/12 x minus 8/12. So y is equal to, so that's 24/12 over minus 8/12. That's 16 over 12, which would be 8 over 6, which would be 4/3. So anyway, 4/3 plus 1/12 times x. So let's get, y of 10 is approximately equal to 4/3 plus 1/12 times 10. So that's 4/3 plus 10/12, which would be 5/6. So that's 8/6 plus 5/6, which is 13 over 6. And that is C. Dun, dun, dun. Look at us go on a Saturday morning. Okay, so pause video if you need to. Number 19. We want to take the limit as x approaches 0 of 4x squared over e to the 4x minus 4x minus 1. Now, if you plug 0 in, you're going to get indeterminate form. You'll get 0 over 0. So it needs more work. But you don't want to try to do like we did in chapter 1 and try to factor stuff and all that jazz, factor and cancel. Let's use L'Hopital's rule. So we're going to take the derivative. So the first derivative is going to be 8x, all right, the derivative of 4x squared. And then the derivative of the bottom would be e to the 4x times 4, so 4e to the 4x minus 4. Now, if you plug 0 there, you're still going to get 0 over 0. But you get to do this as many times as you want. Take the second derivative. All right, so the second derivative, the top is 8. The bottom is 16e to the 4x. Now you can plug in 0, limit as x approaches 0. It's going to be 8, and when you plug 0 in here, it's 16 times e to the 0, which is just 16 times 1. That's a half. And let's hope that's one of the answers. It is B. Fantastic. Number 20. All right, it says g of 0 is equal to 20. And g of 10 is equal to 220. Remember, that's the x value, that's the y value. That's the x value, that's the y value. Which of the following must be true between 0 and 10? Well, what we're going to need to do to answer these questions is get the slope. So the slope of the secant line, that's just y2 minus y1 over x2 minus x1. So 220 minus 20 over 10 minus 0. 20, that's 200 over 10, which is 20. All right, so somewhere on the interval, according to the mean value theorem, the slope of the secant line is equal to the slope of the tangent. So somewhere g prime of t has to equal 20, somewhere in that interval. Okay, because that's our slope of the secant line. So that is B. They are going to test you somewhere on this test. Somewhere they are going to see if you understand the mean value theorem. All right, so you've got to be ready for that one. All right, let's move on to 21. Okay, 21 is another one I want you to star. Okay, so one to go back and study, one that's a little bit different. It says take the derivative of an integral, and our upper limit we have an x, and then natural log of t squared plus 1 dt. They are going to see somewhere, if you understand this fundamental theorem of calculus, and we did not touch upon this in our lectures because I was waiting until the AP study to teach you how to do it. But what you do to take the derivative of that is you plug the upper limit into t and then multiply the whole thing by the derivative of the upper limit. So you would have the natural log of x cubed, and we have to square that, x cubed squared plus 1 times the derivative of x cubed, which is 3x squared. So that's going to be 3x squared, let's bring that out front, natural log of x to the 6th plus 1. And that is option C. Brilliant. Okay, the last one I'm going to work on this video. I'm going to have to put the test into view. I hope you can see it. But you've got a slope field. And it wants to say which of the following is the differential equation. And this is kind of a trial and error process. But what you want to do is see it says dy dx is equal to an equation. Can you see that when x is 0 and y is 0, the slope is 0? Okay, so it says that, let's go ahead and write that down. When x is equal to 0 and y is equal to 0, we know that dy dx is equal to 0. So option A says dy dx is equal to x over y. Well, if you plug 0 over 0, well, that's undefined. That's not the slope. We know the slope is 0, so that's a big no. B says dy dx is equal to minus x over y. Well, that's still going to be 0 over 0, so that's not 0, so that one is a big no. Now C, it says that dy dx is equal to x times y, 0 times 0. That does equal 0, but let's not circle it yet. Dy dx for part D says negative xy, which would be 0 times 0, also 0. So A and B are right out. Those are eliminated. So it could be C, could be D. All right, I'm going to just look here and see if I can find one that has a slope of like a 1 or a negative 1, something easy to read. And you can see right here, right there, when x is equal to 2 and y is equal to, that'd be a half. Okay, when x is equal to 2 and y is equal to a half, dy dx, the slope is equal to negative 1. Okay, so that you've got like a 45-degree angle there, negative 1. So let's see if C or D satisfies that. So if you plug in on C 2 times a half, you get 1. So that's not it. That's not negative 1. But if you plug in negative 2 times a half, that does equal negative 1, which is it. So the answer is D. Very much a trial and error process. This would be another good one for you to star and go back and study as the test draws near. You want to go study those that we didn't really cover that well in class, because the ones that we did cover in class, you know, you're going to ace those. All right, that's the end of this video. The next video will be cover 23 through 30.